Hello, today we're going to talk about variation models. So, the first thing that we're going to discuss is how to determine the variation model. So, we have learned about direct and inverse variation equations that are in the form of y is equal to k times x to the power of n, where n has to be an integer and n cannot be 0. We normally see this written as y is equal to k times x to the power of n as well, where a and k are both the constants of variation. A and k are the same thing. So another thing that we can call these we can call these variation or power models. And the reason why we call them power models is because your exponent is a power, okay? So if we look at the graphs here, we have direct variation. Anytime we have direct variation, the graph is going to pass through the origin or 0, 0. Anytime we have inverse variation, the graph is going to be what we call asymptotic or asymptotic to both of the axes, meaning that it's going to get very, 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 very close, but it is not going to touch. Okay? Before we get into the example, I want to reiterate something. So remember, the general form of a variational power model is going to be y is equal to k times x to the power of n here. And we have to understand that with direct variation, n has to be greater than 0 or positive, and with inverse variation, n will be negative or less than 0. And that is because of laws of exponents, because for instance, if I have y is equal to a times x to the power of -1, if I want to make that exponent positive, it will be y is equal to a times 1 over x, because remember, a negative exponent means that you have to take it to the opposite side for your exponent to turn positive, or basically the negative exponent just means reciprocal. So the reciprocal of x is 1 over x. And if I do a times 1 over x, I just get a over x, which means I would just have this inverse variation model here based off the laws of exponents. All right, so just remember, direct variation means the exponent is positive. Inverse variation means your exponent will be negative. So let's look at an example here. It says the amount of weight A that a person lifts in kilograms is directly proportional to the square of their runtime R in 15-minute intervals. The graph showing the relationship between A and R is shown to the right. Find the equation of the variation model. So we can already tell by looking at this graph here that it is direct variation because it goes through the origin. Okay, it goes through the origin. So I would know that the amount of weight A is directly proportional to the runtime squared, which means that my equation is going to be written in the form of A is equal to k times r squared. So I need to find my constant of variation. So the way that I'm going to do that is I'm going to select a random point. So the point that I'm going to select here is going to be 2, 3. Okay, so that means if I select 2, 3, I'm going to end up getting 3 is equal to k times 2 squared. Okay, because remember, 2 is R, 3 is A. So if we simplify, we're going to get 3 is equal to k times 4. And if we divide both sides by 4, we end up getting 3 over 4 is equal to k. So because I know that that is my constant of proportionality, we know that the equation is going to be A is equal to 3/4 times R squared. All right. So now let's talk about using technology to find variation models. So sometimes it won't be as easy as doing that, but you can use a calculator. All right. So variation models are also called power models, as we have already discussed, being that the variable is raised to a power. Finding the equation of a power model is very similar to finding the linear regression equation. So in order to find the variation model using the TI-84, we are going to follow the steps below. You are going to press stat, then you are going to enter in your data into L1 and L2. Remember, X values are independent variables going to L1, Y values are dependent variables going to L2. Once you put your data in, then you're going to press stat and go over to calculate, and then you're going to select power regression. All right, so let's look at an example here. It says a financial analyst observes a cryptocurrency account. The table below shows the age and value of the account over time. So the first thing they want us to do is to draw a scatter diagram of the data and discuss the shape of the graph. So what I'm going to do is I'm going to make myself draw my axis, and then I'm going to label them. So my X values, or my age, is going up to 17. So I'm going to go by fives. So I'm going to label the major grid marks, or the major lines, which are the bolder lines. I'm going to label those in increments of fives. And then the value, the highest amount is 99 and the lowest amount is 4. So I'm going to label the y-axis in increments of 25s. All right, so if I plot these points, I'm going to have 699.9. So that's going to almost be here at 100. And I'm going to zoom in just a little bit. So somewhere up here. And then we're going to have 8. And that's 42.8. So I go to 8, and then I go up to, I got 25, 30, 35, 40, 45, 50. So I'm going by fives on the y-axis for each individual one. So if I go 25, 30, 35, 40, so 42.18 is somewhere in here. Then I have 11 and 16.23. So I go to 11 and 5, 10, 15, 16 is going to be a little bit above that. So that's going to be here. Then we have 13 and then 9.83, which is about right here. And then we have 17 and then 4.40. So 17 and then 4.40 is approximately right here. So we can tell based off of this graph that this looks like that this is going to end up being inverse variation or inverse power model. So we need to find the equation. So we're going to let the calculator do it. So press stat, edit. And then we already know, and let me put here that, of course, the value is my y here. We're going to type in all of our x values. So 6, 8, 11, 13, 17. And then we're going to go over, we're going to do 99.99, 42.18, 16.23, 9.83, and then 4.40. All right, so once we do that, the first thing that I'm going to do before I find the equation is that I'm going to turn my stat diagnostics on by pressing mode. And I'm going to go down to stat diagnostics, and I'm going to turn it on. And the reason why I'm doing that is because I want to see how strong this relationship is, meaning that I need to see the value of R. So I'm going to go back to stat, go over to calc. Then I'm going to go to power regression, which is my function A here. I know my X values are in L1, the Y values are in L2. I go down to calculate. And this is what I end up getting here. So it tells me that my equation is in the form of y is equal to a times x to the power of b. And they have told us that a is equal to 21, 5. I'm just going to round it to the nearest whole number. And it's telling us that b is equal to negative 2.99, which is very, very close to negative 3. So if we were to write this equation out, it would be y equals 21,567. This is approximately. As a matter of fact, let me use the correct notation. I'm going to use the approximate symbol here because we round it and it is not exact. Y is approximately 21,567 times x to the power of negative 3. So you could write it like that. Or if you wanted to, you could write it with the exponent being positive. Which means that you will have 21,567 divided by x to the power of a positive 3. And we know that that is inverse variation. And we can tell that the R is a negative 0.99999, which means that R is very, very close to negative 1, which means that this is a very strong negative correlation. Okay, so that is our power model. So either or would be your answer here. All right. So now let's look at C, because we now have to estimate some information. Okay, we have to estimate some information. So C, it says, estimate the value of the account that is 28 months old. So if we already know that the equation is y is approximately 21,567 times x to the power of negative 3, then we just substitute in 28 months because months is the x, so we just plug in 28 there. So that's going to be equal to 21,567 times 28 to the power of negative 3. And when I type that in the calculator, I end up getting that this is approximately worth, or the value of the account at that point is approximately 98 cents. That is the value of the account. All right. So if you have any questions on the models or how to use the calculator, please let me know or let your teacher know, and have a great day.